Hello guys, today I am going to discuss about the SR flip-flop. First of all, we should know what is flip-flop. It is a bistable logic element with one or more inputs and two outputs. It is a 1-bit memory cell. It can store 1 bit of information. Now what is SR flip-flop? SR flip-flop is also known as a SR-lets. It can be considered as one of the most basic sequential logic circuit. Sequential logic is a type of logic circuit whose output depend not only on the present value of its input signal but on the sequence of the past input. In SR flip-flop, S stands for set and R stands for reset. Now, this is the logic circuit of the SR flip-flop. Here, in this circuit, we use two NOR gate. Now, we will cross-couple these two NOR gate. That means the output of the first NOR gate is connected to the input of the second NOR gate. Similarly, the output of the second NOR gate is connected to the input of the first NOR gate. And this is the block diagram of the SR flip-flop. Here, Q and Q bar are output and Q and Q bar are complement in all the flip-flop. When Q equal to 1, flip-flop is always known as set, and when Q equal to 0, flip-flop is always known as reset state. Now, let us see how it works. Before saying this, we should know the NOR truth table. This is the truth table of the NOR gate. Here, there are two inputs and one output. If inputs are 0, 0, then the output is 1. If the inputs are 0, 1, then the output is 0. And if the inputs are 1, 0, then the output is 0. And if the inputs are 1, 1, then the output is 0. Now I am going to explain how the SR flip-flop works. Now first, let us assume that S equal to 0 and R equal to 1. From this truth table, we can see if any input of the NOR gate is 1, then the output is going to be 0. Here R equal to 1, so this will make Q equal to 0. Now Q is connected to the input of this NOR gate, so this will reflect here. We have 0, 0 as the input for this NOR gate, and when the two inputs are 0, 0, it will give us the output as 1, that is Q bar equal 1. Now we can see that Q and Q bar are complement to each other. Now here Q equal to 0, so we can say that this flip-flop is in reset state. Now we can write here that when S equal to 0 and R equal to 1, then Q equal to 0. And in the remark, we can write here that the flip-flop is in reset state. Now, if we change the input to 0, that means S equal to 0 and R equal to 0. Now I change only this. This input remain same for this gate. Therefore, if any input of the NOR gate is 1, then we are getting the output is 0. And for this gate, the output is 0. That is Q equal to 0. There is no change in the Q value. Therefore, we can say that it is in the same state. So we can write here in the truth table of the SR flip-flop, when S equal to 0 and R equal to 0, then Q value is the same. And we can write in the remark, there is no change in the previous state. Now, in the second case, when S equal to 1 and R equal to 0, therefore, if S equal to 1, the output of this NOR gate is 0. That is Q bar equal to 0. And this Q bar is connected to the input of this NOR gate. So we have 0 here. Therefore, the output of this NOR gate equal to 1. So we can say that this flip-flop is in set state. Therefore, we can write here when the S equal to 1 and R equal to 0, then the Q value is 1. And in the remark, we can write here that the flip-flop is in set state. Now, if we change the value of S is equal to 0 and the remaining inputs are same, then we get Q bar equal to 0. And this Q bar is connected here. And the output of this gate, that is Q equal to 1. And again, there is no change. And we can write here when S equal to 0 and R equal to 0, then the value of the Q equal to 1. And we can write in the remark that there is no change. In the third case, when S equal to 1 and R equal to 1, and from this truth table, if any one of the input of the NOR gate is 1, then the output is always 0. Therefore, when R equal to 1, it makes Q equal to 0. And when S equal to 1, it makes Q bar equal to 0. Here, Q and Q bar are same, which is definitely not true. They must be complement of each other. Thus, S equal to 1 and R equal to 1 is not used. So we can write here when S equal to 1 and R equal to 1, the value of the Q and Q bar are same, which is not used. Therefore, we can say it is in forbidden state. And this is the basic of the SR flip-flop. So hope you all understand this. Thank you.